There's something quite exciting happening at the University of Oxford this summer. A team of undergraduate physicists, biochemists, biologists, chemists and engineers are working on a synthetic biology project to enter into the annual iGEM competition. iGEM, or Internationally Genetically Engineered Machines, is a socially driven research competition in the field of synthetic biology. Participating teams of undergraduates from all over the world work throughout the summer with the aim of using synthetic biology to create solutions to major social and environmental problems. Whilst the competition has a prominent laboratory-based aspect, it is just as much about beyond the lab work, in the form of outreach and human practices, with a heavy emphasis on popularising the world of synthetic biology.
And treating diseases with genetically modified bacteria, is that something you'd ever think about?
Great idea.
There's a resistance to antibiotics, so yes, I would say it would be a concern.
A summer of hard work culminates in the showcase and presentation that the iGEM team will give at the Giant Jamboree. This takes place in Boston at the end of September, and teams from around the world gather here to showcase the work they've been doing. So what is it that we're trying to solve? Antimicrobial resistance is an increasingly serious threat to global public health, and it's an issue in all parts of the world. One of the ways through which bacteria can confer themselves protection against antimicrobial drugs is by growing a biofilm. A urinary tract infection is a medical condition that is amplified by this bacterial ability to produce a biofilm. Here's one of our team members to explain a little bit more about the problem that we're trying to combat.
UTIs are one of the most commonly acquired bacterial infections, and they represent a huge problem, especially for women, as more than 50% of women will acquire one during their lifetime, and they cause a lot of pain and a lot of discomfort, and we're trying to sort out those issues using synthetic biology to try and create a novel treatment for the issue. The most common way of treating it now is using antibiotics, which is presenting a huge problem for the world in the form of antimicrobial resistance, and what we're trying to do is circumvent that problem by using synthetic biology to create a bacteria that can sense and then take out urinary tract infection causing bacteria. This is an illness that's strongly associated with healthcare provision due to the fact that many people pick up the infection whilst in hospitals or doctors' clinics. So we think it's a particularly important issue that we help doctors out in making sure that they cure people's problems as they come in and not give them more infections when they turn up. So most urinary tract infection causing bacteria have what's called a biofilm, which is a kind of protective slime that sits over them whilst they're in the urinary tract. And the reason why this is particularly important is because most antibiotics aren't able to fight their way through to then kill the bacteria. So where our solution comes in and circumvents this is that the live genetically engineered bacteria can break their way through the biofilm with one product while also killing the bacteria with a different one. And so that means that our solution kind of deals with the issues that antibiotics currently can't deal with.
Both antimicrobial resistance and other problems associated with biofilm formation are huge issues in their own right, but they're especially problematic when combined. The bacteria are already constantly evolving to afford themselves more innate resistance to antibiotics, but by producing biofilms they have this extra protective layer that shields them from the drugs even more comprehensively.
So one of the ways in which we think that our products can be particularly useful is when patients have been catheterized. So a lot of people develop UTIs when they've been catheterized for something completely different and then begin to show symptoms afterwards. Because our product will be catheter associated, we can both stop people developing UTIs in the first place while also treating people who have already had to be catheterized. So we think that our idea can sort of attack in two ways, and we find that to be particularly useful and hopefully useful to others.
Clearly we're trying to address a huge issue and a prominent problem this year. To find out more about how we intend to solve it, be sure to follow our blog, check out our wiki and tune in for future episodes, where we'll be explaining more about our work, documenting our progress and giving the occasional web tutorial on synthetic biology. Thanks for watching, and we hope to see you soon.